Welcome back to Advent of Code 2024, day 15. So, hello, the Four Fox. I think my girlfriend hates me. How's your day going? Oh, I'm sorry to hear that. My day is not done much today. I just had lunch and now started on Advent of Code, which I've been doing every day. I think however this problem goes will determine how my day goes, pretty much. I've been doing this every day this month. Right, warehouse woes. You appear back inside your own mini-submarine. Each historian drives their mini-submarine in a different direction. Maybe the chief has his own submarine down here somewhere as well. You look up to see a vast school of lanternfish swimming past you. Lanternfish was from this one. Don't quite remember this one. On closer inspection, they seem quite anxious, so you drive your mini-submarine over to see if you can help. It's probably because you're driving a submarine towards them. Because lanternfish populations grow rapidly, they need a lot of food, and that food needs to be stored somewhere. That's why these lanternfish have built elaborate warehouse complexes operated by robots. Of course they have. These lanternfish seem so anxious because they have lost control of the robot that operates one of their most important warehouses. It is currently running amok, pushing around boxes in the warehouse with no regard for lanternfish logistics or lanternfish inventory management strategies. Right now, none of the lanternfish are brave enough to swim up to an unpredictable robot so they could shut it off. However, if you could anticipate the robot's movements, maybe they can find a safe option. The lanternfish already have a map of the warehouse and a list of movements the robot will attempt to make. The problem is that the movements will sometimes fail as boxes are shifted around, making the actual movements of the robot difficult to predict. Okay. As the robot attempts to move, if there are any boxes in the way, the robot will also attempt to push those boxes. However, if this action would cause the robot or box to move into a wall, nothing moves instead, including the robot. The initial positions of these are shown on the map at the top of the document the lanternfish gave you. So we've got boxes, we can push them around apparently. The rest of the document describes the moves that the robot will attempt to make in order. Alright. Here's a small example to get started. So were the robot to attempt the given sequence of moves, it would push around the boxes as follows. So it starts here. It goes left. It goes up. Up. Right. Right. Ooh, so we push a whole bunch of boxes. Oh dear. Okay. I'm guessing ampersand is the robot? Yes. You push those boxes down. Okay, this is... seems like it could be a bit tricky. Okay, so he pushes all the robots. After the robots finish the moves, the warehouse would look like this. The lanternfish use their own custom goods positioning system, GPS for short, to track the locations of the boxes. The GPS coordinate of a box is equal to 100 times its distance from the top edge of the map plus its distance from the left edge of the map. The lanternfish would like to know the sum of all boxes' GPS coordinates after the robot finishes moving. Okay. As long as we code the box movement correctly. There's no real catch to this, I think. You just simulate all the movement and then... Huh. Alright. And this is the puzzle input. Okay. Interesting problem. This is part 1. Part 2 will be something extra, I guess. Alright. So, we're gonna... Let's pause the input then. So we wanna just... Okay. So we want to reuse some past code. Let's say... kind of like this. In fact, we want the grid as well. Okay, so we get the grid. Okay, so for each row equals let's say so we strip the line. Well, we need to check if it starts with hash. If it starts with hash, then we do this stuff. We want to build the grid. Row equals line.strip. We want to cast that to a list. Because we want to change characters. Move things around. Grid.append row. Don't they all start with pound? Not the final rows. So we want to do some logic for these ones, and different logic for these ones. Hang on. Yeah, it's fine. So it starts with hash, we do that. Else, once we want moves equals just store it in a list for now. Else we want moves.append line.strip. And then after we've done that, we can say moves equals dot join moves. So we join it into one big string, because they said that the lines is irrelevant. This is all just one long string. And this line here doesn't matter, because it will get stripped out anyway. So we can just append an empty character to moves. So... oh, we need to find the robot. If... so it's ampersand in row. Okay, let's move this up. Actually, no, we don't want that up there. Put it down here again. Then... so the column J equals row dot, is it find? Not find. Index. Okay. Oh yeah, it's a list, not a, if it was a string, it doesn't matter. Robot pause equals ij. So we found the robot pause. Also, let's get rid of the robot, just replace it with empty space, because we don't actually, we know where the robot is, we don't want him stored in the map. We want the map to reflect the environment, so we found where he is. J row J equals, so it's just gonna be dots. Dot. Now we can replace robot pause with the pause. Like that. That turns it into a pause. That's more useful. Quality hash is inbounds. Get neighbors. Yeah. But we don't need neighbors. We can comment that out for now. I don't think we'll need that. We don't really even need is inbounds. We'll leave it in there. So, alright, well, it's 1:30 AM. I should probably get to bed. Alright. Sleep well. I will continue hacking away at this. Yep, good to see you again. Robot pause. Okay. So I think we just want to know... oh. Fine, let's just print the grid. I want to see what we're dealing with. For row in grid, print dot join grid, and then print moves. All right, make sure we've actually parsed the input correctly. Yep. Right. And we've got one big list of moves. Okay. Okay. So... okay, get rid of that. Alright, so now we'll have to just simulate the set of steps. So we know where the robot pause is. So we want to say for car in moves. Just make a map here. It's just gonna go. It's gonna map each of these directions to a delta. So it's gonna be like. So we have up maps to pause -1 0. That maps to pause 0 1. V, is it big V or small v? Small v. Okay, that is directions, or let's call it DIRS. So the destination, dest equals robot pause plus DIRS car. So that tells us where the robot's trying to go to. All right. If grid dest.i dest.j is hash, can't do anything, just continue. Elif grid dest equals dot, then we simply move the robot there. Then we just say robot pause equals dest. Alright, those are the easy cases. The only other thing he could be looking at is a box. We'll just write this out explicitly so that we know that that's what's happening here. The box is that character. That's an O. That's a capital O. Okay. Can't really tell. I mean, we don't need the hash case. We could just say we don't do anything in that case anyway. All right, so trying to push the box. So I reckon we want to find the next. So we want to look past the box, potentially at the sequence of boxes, until we find either a dot or a hash. If it's a hash, then we can't move the boxes. If it's a dot, we can. Right, so we want to say let's say temp equals dests, right? So temp, make a temporary variable looking at this one box, and we say while grid temp.i temp.j is still, while we're still looking at a box, just keep pushing forward. Just keep saying temp plus equal. Just keep walking in the same direction. So when we break out of that, we're looking at either a hash or a dot. And because there's hashes around the outside, we don't actually worry about going out of bounds. So we say if we're now looking at dot, so what do we want to do? We want to, so basically we want to move that whole chain of boxes. So but only two things changed: the box we're pushing and this destination. So what we want to say, grid, that changes to dot. That changes to box. And robot pause equals dest. And if that's not true, it's a hash, so we don't actually do anything. So that should be it. Then after that, let's just see if that runs. Okay. After that, what are we doing? We want to sum of all boxes GPS coordinates. Okay. $100 times its distance from the top edge of the map plus its distance from the left edge of the map. So basically it's indices. I and J. Okay. Alright, so for I in range N, for J in range M, if grid IJ is a box, so we want just call it GPS equals 0. GPS plus equal, so it's going to be 100 times I plus J. One, 4, 3, 8, 1, 6, 1. Okay, before I try this, let's also just see what the grid now looks like. See, that looks kind of right, because you can see a lot of boxes are now stacked up against walls, especially around the edges. And boxes are grouped together as well, because they're being pushed. Yep. So something's going right. See if it's completely correct, though. Correct. The lanternfish use your information to find a safe moment to swim in and turn off the malfunctioning robot. Just as they start preparing a festival in your honor, reports start coming in that a second warehouse's robot is also malfunctioning. This warehouse's layout is surprisingly similar to the one you just helped. There is one key difference. Everything except the robot is twice as wide. So hash is replaced by hash hash. O is replaced by that. Dot is replaced by dot dot. At is replaced by at. Okay. Oh dear. Oh boy. Okay. So moving horizontally is as before. Vertically, you can have some interesting situations come up. So... So it didn't really... Okay, I need to think now. So let's code everything except for the vertical movement then. We want to just fetch from the input again, I suppose. Just reread the input. So we've got, unless we... Hello, level 27. Are you doing advent of code? Alright, so I think this grid is all changed. We can't reuse it, so we've got to say, just take this code here. I don't think we even need this method. In which case we can just move this up to the top of the file here. And then when we get the robot pause, we can just say it's a pause like that. We don't need that. Not doing Advent, just losing my mind in my Saturday. Hope you're doing well. Yeah, I'm doing well. The problem is, so far not that tough, but we've reached part 2 now. It could be a bit tougher. So part 2. Let me just make sure we've still got the same answers before. One, 4, 3. Okay, yeah, okay. So we don't want to change the moves. Grid. So we read the input again. What's the task? I've never done anything like this. The task is this problem here. Hang on, I can actually paste it. Although I don't think you'll be able to read part 2 though. Part 2 you only unlock after you beat part 1. But I just did part 1. Basically it's a coding problem. Every day a different coding problem is released. Usually mathematical in nature or have some sort of data-oriented or thing or simulation. In this case it's more of a simulation. We're simulating a robot moving about a board and pushing boxes about. Seems straightforward enough. Do they get more difficult as time goes on? Part 2 tends to be more difficult than part 1. So part 2 is like an extension of part 1. In this case, whatever the map was for part 1, it's now sort of scaled up a bit, but the boxes have changed in their properties, so you can no longer just push them around in a simple way. If you push, it's a wide box, so if you push this wide box up, it pushes both of these wide boxes because it's touching both of them essentially. So we'll have to deal with that when that situation comes up, but right now I can code horizontal movement easily because you just push here, you just push left and they just move left from here to here. That's alright. Actually, thinking about what to do for this. Alright, so let's just start with what we know what to do. Change the map to... Okay, row equals list of line dot strip. Alright, so we need to apply the replacements. So they said replace... Do you have to use Python? You can use, no, you can use any language you want. It would be pretty simple to get adjacent tiles in Prolog. Well, getting adjacent tiles is easy in Python too. I've already got like a custom pos class here. So it handles like addition of vectors and neighbors and stuff. Well, I just deleted the neighbor function. I don't think we'll need the neighbor function now. Alright, so over here we want... Okay, so we want dot replace. So the replacements they want are... hash with double hash dot replace O with square brackets dot replace dot with dot replace ampersand with ampersand dot. Wait. That becomes a problem now. Which order do these get processed? It's from left to right, isn't it? Yeah, so that's okay then. If we put that at the end, it's not going to interfere. These are all independent. But this one creates dots. This one creates a dot, which we wouldn't want to expand, but that's fine. Okay, so that is the new row. And then this is as before. If at is in row j equals row to index row plus equals ij. Alright, let's see what this new grid looks like. Looks okay. $24.48. What was it before? I love how close Python is to English, but always gets confused trying to make sense of long list comprehensions and stuff like that. Yeah, they can be confusing. And weird looking. Pause. 24.24. 24.48. That makes sense. It doubles. Because everything gets pushed. Alright. Okay. That seems fine. So we've now got the new map. We have to... do all this again. So for each move, the destination the robot is trying to go to is that. If the destination is a dot, we just go there. That's easy. We don't have boxes anymore. If it is in, so if it's one of these characters, that's where it gets complicated. And a hash we just ignore. So horizontal movement's the easy one. So let's just do horizontal movement. If what am I trying to? Okay, if car in that, so we're moving horizontally. We basically do this sort of, but not quite. So temp equals dest. Okay, so we look at the box we're pushing while, and then we keep pushing, we keep moving temp forward and forward until we come after the row of boxes. Okay. If the space after the boxes is an empty space, then we want to push all the boxes. Except in this case, we don't just flip the first and last characters. We need to push all the boxes in one go. So we want to say for so temp is looking at the dot. Okay, so we want to say while, so we want to move backwards now. While temp is not equal to dest, the box we're pushing. As soon as temp comes back to the box we're pushing, we're done. So we say we swap so boxes touching other boxes get moved as a result of the first being pushed. Yeah. Logically, I would think to move the secondary boxes relative to the position of the first. But how do you even know the first box's coordinates when it's 2 characters in width? I'm either too tired or dumb for this. First box's coordinates. We know the first box's coordinates because we have a pointer to it right here. So we know where the robot is, and we know the coordinates of the spot that the robot's pushing. So we know I have a variable dest, which is basically that. So I want to swap grid And this... hang on. Previous. I'm going to have to make a new variable. Previous equals temp minus dies character. So we have to move back. We don't have a minus method here. We have to add subtraction. Previous is temp minus, so that's the previous one, and we want to say grid temp. Didn't even know Python had operator overloading. Saw it once in C++ and it scared the shit out of me. It's, yeah, it can be scary. It can be dangerous because if you don't keep track of what you've overloaded, you could screw things up massively. But yeah, it's certainly useful if you're making like vector classes and stuff like that. Weird. So we swap these two in place, and then we say temp equals prev. Just pull temp back. Keep doing that until temp is now sitting at dest. That means we've basically pushed all the boxes. And finally, robot pause equals dest. So that is horizontal movement. So that's the easy one. Let's see if this runs. Robot pause. Oh, damn. That should be a pause, not a tuple. Okay, so it ran. Let's see what the grid looks like, see if horizontal movement seems to be happening. That does look like horizontal movement is happening. So the boxes retain their shape. We haven't screwed up their shape by mixing the brackets around or anything. And we see a lot of chains horizontally but not vertically. So that's a good sign. Also, they're getting pushed against walls. They're getting stopped by walls. Alright, now we do the tough bit. So if it's vertical, I think, okay, what we first what we want to do is do like a sort of depth first search, to find all the boxes which are being pushed here. Then we want to check all the spaces in front of them and see if they're all empty. If there's even a single wall, then we can't push the lot, I believe. Okay. So first we need to... And now that I think about it, this will probably work for horizontal as well. So we don't actually need a separate horizontal thing. It just happens to be simpler in that case. But I think we will actually just... This will be the only thing we need. Alright, so... Find all boxes, box positions getting pushed. So this is, we know one thing we want. This is dest is the part of the box we're pushing. And we want just a set of all the boxes that we're finding here. So while the queue has stuff on it, current equals queue.pop, so pop things out of the queue. Now we don't need a neighbor function here, we just have two neighbors to check. One, if it's a bracket, find the other bracket and add that, because that's getting pushed, you know, by the laws of physics. It's attached. So so we want neighbors equals just a set of neighbors. So the first neighbor we append, there's at maximum two neighbors. Yeah. If I'm assuming you have a Chomsky background, could be wrong, but I'm amazed at how fast you chose an appropriate algorithm for the problem. I really struggled with pathfinding in school. I do have a Chomsky background, and I've done quite a bit of like pathfinding in like AI challenges and bot programming challenges, mostly with a site called Coding Game, which I highly recommend. So it's more focused on AI than generic algorithms, but like sort of like video game AI. So it's mostly pathfinding and controlling bots, moving them around a map and stuff like that. So yeah, I've got a bit of practice, but the reason I went for depth first search here is just because it's the simplest to code. Any kind of search would work really. Breadth first, depth first. I mean, you don't need anything more complex than that. You don't need Dijkstra or A star because distances are just unit. Everything is distance 1 from their neighbors, so you don't need anything like that. So yeah, when in doubt, I just go with depth first search. Easy to code in Python. Just pop it on the list. So if grid current.I current.j we were only taught A star. I'll have to read about first search algorithms. You were taught A star without being taught the basic version? So A star is like an extension of Dijkstra, and Dijkstra is an extension of breadth first search. So it would be really weird to jump to A star without learning breadth first search. And depth first search is just an alternative to breadth first search, but they both have their uses. Why would they jump straight to A star as an extension of those two of those? I would not recommend doing that at all. A star is significantly more complex than Dijkstra, and in turn that's more complex than breadth first search, so I don't know why they would jump to that. Maybe that's why I struggled. I can't imagine trying to teach people starting from A star. You got to build your way up to it. You don't even see the motivation of using A star until you see what more it's capable of that can't be achieved with like breadth first search. Yeah, that's strange. But yeah, I mean, if you like even slightly understood A star, then you probably won't have trouble understanding breadth first search, because it's very natural and it's actually kind of what we do anyway when we're trying to search through a maze and stuff. It really actually depth first search is the one that really replicates how we as humans would navigate a maze, like going down a path, backtracking, taking the next junction, and so on. So depth first search is probably the most relatable, the most understandable. It's not exactly a school known for computer science either. They're called Maryville University. I see. That's in America. And you were coding that in C++ as well? That's pretty tough. Like it's hard enough to code A star, but to code A star while having to worry about C++ pointers all over the place. It was in Python. Okay, that's a bit better. A bit easier to understand then. Just turn the AC off. Alright, if grid equals, so if it's a left bracket, then we want neighbors.append current plus 0, 1, else neighbors.append -1. So that gets us the other side of the box. And then the other neighbor we're interested in is the one that's directly in the direction of the pushing, which could be the same thing as this. If we're pushing it horizontally, then we could end up with this. Yeah, so I think horizontal is actually not needed here. This covers both cases. Right, so we want neighbors.append current plus dirs let's just get rid of the horizontal thing for now. Let's just go like that. Start with this. All right. Okay, so we've got potentially two neighbors here. No, not potentially. There are two. We've added two. But we don't know if they're valid neighbors to add to the queue. So we now say for neighbor in neighbors, if neighbor is in boxes, we've already found it before, we don't care about it anymore. Alright. If otherwise, if grid it is a box type, then we're going to add this to the queue. So we say queue.append neighbor and visited, because we've now visited this. Oh, boxes dot add neighbor. So if they're both the same, these two neighbors are identical, then we'll add it once. And then we won't add it the second time because it will now be in boxes. So if this works correctly, then boxes should be populated with all the boxes that will get pushed. So that's step one. Step two, find all spaces in front of boxes getting pushed. So this we've spanned out the boxes. Everything now in front of them is either a wall or an empty space. So for box in boxes, so go through all of them. Spaces equals set for box in boxes. Let's call it ahead. Just try and be more descriptive. Space ahead equals box plus direction of the force. If space ahead not in boxes, i.e. this is an actual space and not just another box, that's spaces dot add space ahead. We can also short circuit here. We can say if we found a hash, if grid space ahead I space ahead, so this is just an optimization, .j equals a hash, then we don't need to go searching for other spaces. We already know we cannot push these boxes. So just break out of this for loop. Okay, so at this point here, we find out if we can push them. If all, and basically this thing again, space.i space.j is an empty space for space in spaces. We can push the boxes. Now, oh dear. Pushing them is also tricky. So we have to oh man, how do I do this now? We'll basically have to do that sort of like in a queue and only push to the things at the end. Okay, fine. So what we want is I need to have a think. Alright, we order them where we only start with the boxes furthest away, push those, then move backwards. So we have to order them according to define some inner method here called define push distance of the box. Let's say the push distance of a box is how far away it is along the axis we're pushing. So it's basically how many of this vector we have to add Hang on, how do I phrase this? Just check if let's just do the separate cases. In horizontal, then it's the x-axis. So we want to say return the absolute value of box.j minus, what was the original box? Dest. Oh, that's so long ago that we wrote that. Dest.j. So else return abs. There's probably a cleaner way of writing this, but let's just do it like this. Dest.i. Alright, we're saying that is how far they are away in terms of the direction of force. And now we want to say for box in sorted boxes, key equals push distance, reverse equals true. So this says we want to take all the boxes from boxes, but we want to sort it according to the push distance and in reverse order. So we want to say take the furthest boxes first, then come backwards. And for this box, we want to move it forward. So we want to say roughly what we did before, which is this. Well, not really. We want to say grid box.i box.j grid box space ahead equals that. Man, this is getting complicated. So we're swapping them, saying swapping this box with the space in front of it. Do we think this will work? So it runs. Do we think we're actually pushing them correctly? Do we see chains of... Like, if we see sort of like pyramid shapes, that's a good sign. That means we're kind of pushing them together. Alright, let's try then. Then what? We need to say... here. GPS. Wait, how do we determine the GPS of these? Closest edge of the box in question. Oh no. Okay. Closest edge of the box in question. So it'll basically be... So if it's in... Okay, if it's this, I think we're gonna just do double and then divide by 2 afterwards. So if it's a left edge, then that is the closest edge. So it only really matters for horizontal distance, doesn't it? Yeah. So you would never actually need to look at the right-hand side of the box. It's always going to be the left edge. Okay, it's not as complicated as I thought it was. Okay, so just do that with GPS. Oh, there's so much that we've done. I don't know, we'll see. 739517 is smaller. Why would that be? Because we've got like double the size. Alright, try it. No, it's too low. It does seem too low, doesn't it? Alright, let's try this then. So we're dealing with this example. So in each... Oh, I forgot one thing here. So we push all the boxes. And there's one very important thing we forgot. So the robot's not even moving about. Robot pause equals desk. We have to move the robot. And we don't. If we don't push, let's try again. well, let me try the big example. Seven three. That's even lower. That doesn't make sense. Fine. It's a different issue. But that was a massive issue. Alright, it's gonna be tricky to debug. Let's get started. Have we... Oh my god. Got whatever very important thing. M is different now. Just define them both again, even though it doesn't matter. N equals length grid, M equals... Only M changes. Try that. 1437981. Why is it basically the same? That doesn't sound right. It's... That can't be right. Like the... So the X... Well, let's try the test example anyway. So, larger example from above. Can't find the... Where's the larger example? It's right at the top of the document. Okay, try this one. $9021. Oh, that's correct. Why is it less? Just feels like it'd be more because there's twice as many. Or do you do 100 times? So the biggest contribution is from the vertical distance. The vertical distance isn't really going to change much. It's just going to be a different number because the boxes are only wide but not tall. So it doesn't really matter if it's more or less. It's going to be roughly the same because the horizontal contribution is so small. That's probably why. Alright, let's try this then. Four, 3, 7, 9, 8, 1. Did we get the same answer for the first? Okay, so... Correct. Interesting. So I just forgot to replace M. Double M. That's the problem when you reuse variables. You should never reuse variables. And I've reused variables pretty much every single Advent code problem we've done so far. The IDE is even screaming at me with those underscores, like shadows variable from outer scope. That was a pretty good problem. It required some good handling of data. It required a little bit of pathfinding algorithm-ish stuff. But it required care. It required care over how you handle pushing boxes. I think I do like my approach. And I don't think there's really any vastly different approach here. You kind of had to find the span of the boxes one way or another and find the spaces in front of them. You can't get around doing that, because I could easily construct a counterexample which would be like a really complex pyramid of boxes and with like one wall. You do need to do that. So I mean, I suppose the order in which you do things, you could just start pushing the boxes, and then as soon as you find a wall, you're like, uh-oh, and then reverse what you did, but... yeah, pushing the boxes in part 2, I would say, was quite tricky. And, I mean, the way I did it, I wrote a lot of code before I even really ran it, so there was a whole bunch of things that could have gone wrong there. So you would want to test. I mean, let's have a look at this. So yeah, so we ended up not using the vertical. Like this covers both cases. So that is a huge blob of code. You would probably want to make it more modular, split it off into methods. It's a bit tricky to do so, but I mean, for example, finding this is kind of like a, you can tie this up as like a depth first search. Well, not this. This can be a depth first search method extracted out of that. But then it has custom. At least you waited until you were done to worry about optimizing. I'm probably not going to optimize or change this. I mean, it runs instantly in terms of time. I was just removing some comments and things. Grid. So we ended up not using... Well, we used equality in the vector. Yeah. I think overall this was a good method. It's just this box pushing thing. That's, I guess it's as complex as it needed to be. There's no simpler way of doing it. Like, it all comes down to a search. I could easily make a whole pyramid of boxes where 1 is pushing 2, 2 are pushing 4, 4 are pushing... So you could push like a massive amount of boxes. So if you can't make this simpler, because then you would miss that case. at least in the first part where you're just pushing a line of boxes, you don't have to push. You don't have to move each box one by one because they all look the same. So you can just swap the last character with the first one. So the first box gets teleported through the sequence of boxes and appears in the empty space at the end. So you only have to do one swap. You don't actually have to move the boxes because they would look the same either way. They all look identical. But yeah, it gets complicated when they have width. Overall, pretty good problem. And it's not one that you can really get stuck on forever. It didn't need any crazy algorithm or clever insight. You just had to simulate the set of steps they've given you. It's just a question of how long that took. If it's really hard to code, then, as I said, you need to make it more modular, split it up into methods, make a depth first search method, make a find spaces in front method if you need to. Doesn't really matter. But you'll get there eventually. There are some problems which, you know, are more mathematical and they require a really clever algorithm. And those are the ones that people get stuck on forever and maybe never solve. Sometimes there's no intuitive solution for a problem. Yeah, when it comes to simulation problems, especially in advent of code, usually you have to simulate every step. There's no shortcuts. That's like... It's like the three-body problem in physics, where you have two or three bodies like attached to each other on a rope. Once you get them moving, you can no longer predict where the balls are going to end up, so you kind of have to simulate their entire span of movement, because you can't predict ahead of time where they'll end up. It's chaos. That's the word. When you have these simulations where robots are pushing boxes around, or things are colliding, or things are multiplying, like in like the Game of Life, which we've had some problems based on before. The Game of Life is a simulation where you have like a bacteria and it expands into new bacteria. Some bacteria die, some bacteria multiply, and that creates chaos. So you can't. There's no shortcuts. You have to simulate every individual step. Hello, DIJ. I've just done it. It was a good problem. One of the trickier ones, I would say. Cellular automata. Yeah, and it's quite applicable to like mathematical biology or fields where they are actually simulating the populations of species or bacteria. Yeah, this problem, I mean, the basic gist of it, and it's pretty easy to describe actually, was you got a robot, you got boxes. It's like those games where you push boxes around, but when you push a box into other boxes, because these boxes have width. So if you've got a situation like this, well, okay, you got a situation like this, so that's the robot, these are the boxes. If he comes from below and pushes upwards, you want the whole stack of boxes to move upwards. But this whole stack could be like a huge pyramid of boxes, or kind of have a lot of weird shape to it. As long as there's not a wall in front of one of the boxes, then you can push the whole stack, and the whole stack needs to be pushed. So there's basically three main phases to that whole process. One, find all the boxes that are being pushed. That's a case of like taking the vector of force, whether it's up, down, left, or right, and for each box checking, you know, if there's boxes above it, and then completing those boxes and then doing the same process. So that's like a depth first search type thing. And the phase 2 is to work out if it can all be pushed, and that's to check if there's any wall in front of any of the boxes. And then phase 3 is to actually apply the push, which is also tricky because you have to... Basically what I did was, starting with the furthest boxes away, just swap their character with the empty space, and then work your way backwards, back to the beginning. Swap the characters and then in the map visually it will look like they're moved. So yeah, as long as you can handle those 3 phases, and they're each tricky in their own right, then you've got it. It was a good problem. I wasn't quite paying attention. How does it know to push the parts of the secondary boxes that are not directly adjacent with the first box? Like, the example shows 2 boxes on top of 1. So, yeah, like this one. And they're both touching, but only half of them. The halves that aren't touching, how do you track those? So every time... So basically, I'm creating a list of all boxes. And it starts with just this one. And I have 2 processes for adding new cells. One is just look in the direction of force. So we get that box part, we get that box part. And then the second way of adding new things is if it's a left bracket, then look to the right and add the corresponding right bracket. If it's a right bracket, look to the left and add the corresponding left bracket. So there's one iteration for completing partial boxes. So that kind of spans left and right. And then there's another step for going in the direction of force. So it's kind of like a neighbor function. It always adds 2 neighbors in each step. One, whatever's in front of me, the way I'm pushing, and one, complete the sides of this box. And if you keep doing those 2 steps repeatedly forever, until there's nothing more, then yeah, that's basically depth first search. Depth first, breadth first, either one will be fine. Breadth first would probably be better, because with the advantage of breadth first is that you actually record you actually know the distance away from the origin you are at each step, because you start with all the close ones, then you move to all the ones which are like distance 1, then all the ones which are distance 2, and so on. And if we know the distances, then that makes it easy for the final step, because we can actually work backwards from the last layer, and so on. Depth first search doesn't give you distances. Breadth first search does. The only reason breadth first search is harder to code, not much harder, ever so slightly harder, is because you need a queue data structure. Which many languages don't really have. Well, they do, but it's sort of you kind of have to apply a bit of custom logic. Python does have a queue data structure which you can import queue, capital Q. You said this is DFS, right? Why would you need to know the distance for a problem like this? The reason I need to know the distance is in the last step, I want to push all the boxes. So I want to basically swap each character with the character in front of it. But I don't want to start from the beginning, because then that'll swap this character with this one, and then it will mess up. So I actually want to start with the ones with highest distance. So in this case, swap this with that, this with that, this with that, this with that. And when I've done that, I can safely move to the ones which are like closer. Swap that with the new empty space that's there. Swap that with the new empty space that's there. As long as I process this furthest to closest in that order, then I'll never I'll never screw up. So it's a way of performing the simultaneous update. I mean, alternatively, you could... Well, it's the same thing, really. Yeah, I think that's really how you have to do it. So you can think of it like those block puzzles, where if you want to move a chain of things, and there's an empty space at the end, you have to move the last one first, and then the next one, and then the next one, and then the next one. Same thing here, really. If we try to move the first one, it's gonna swap with the next block. At least the way we're handling characters in a string here. And then you just screw up and you're not actually pushing the blocks. You're just merging them with each other. Yeah, that was... I think this is probably one of the problems where a lot of people will maybe hit a wall. Because that's not an easy thing to code up. Let's have a look then. Leaderboard. Unfortunately, the global leaderboard's not really much use to us anymore because people are using AI to solve it. Now that's interesting. 15 minutes to solve both stars, so it's no longer like 15 seconds. The 15 seconds ones are usually AI. People are just using AI to solve these, which is kind of sad. 30 seconds to solve part 1, that's... doable, because even before the days of AI, we definitely had solutions in 30 seconds. Whether you can do it for this, I mean, I did copy forward a lot of code. I copied the code which extracts a grid, I copied the code which handles a pos and vectors and all that stuff. So maybe it's doable if you've already written libraries for handling all of this stuff. And this is... so... but then pushing boxes, I don't know. It's kind of borderline 30 seconds. Using AI to solve these, that's impressive. I can't get the AI to do anything other than send me back a copy of my own code, minus the white space. I mean, I tested this before, and it's really... all you do is just say, even the free version of ChatGPT can handle this. You say, and I should clarify, you're not allowed to do this until the leaderboard is filled for this site. Once the leaderboard is filled, and it usually fills within minutes, then you're allowed to use AI if you want to. So, but for AI, you just say, hey, ChatGPT, can you give me some Python code which will solve the following problem? And then literally just paste the entire description of the problem. Like, you don't even need to modify it or leave things out or anything. You can keep the diagrams in, you can keep everything. Just paste the entire problem. And then a lot of the time it'll just give you the code. And even if the code doesn't work first time, you say, hey, this gave me the wrong answer, it's too high. Can you find out what went wrong and fix it? And a lot of the time it will fix it after maybe 1, 2, or 3 prompts. Hex did it for like 2015? Yeah, I did it for like a couple of years. Probably 2015 and 2016. And in most cases it beat me. At least it solved the problem quicker than I could. And I think this AI would be able to solve this problem because there's nothing too crazy. It's easy to understand. We've got diagrams. The AI can understand these diagrams. So yeah, I think it probably would do it. I've tried ChatGPT, Microsoft Copilot, GitHub Copilot, Google Bug, Claude, Llama, all of them, and honestly GitHub Copilot is the only one that's worth a damn for programming. I think I'm going to try Grok soon though. GitHub and MS Copilot should be the exact same, shouldn't they? I don't know anything about them, but I would think even though Microsoft makes both of them, they've probably trained them on different data sets, since GitHub would be more for code and GitHub stuff, and Microsoft Copilot, I assume, is designed for general Windows use. Is it? I don't know, I don't really use either of them. It's for VS. Oh. It's possible they have a lot in common, but maybe GitHub like also does some more languages that I don't know. They're not. Microsoft Copilot is basically GPT plus Bing search. GitHub Copilot is an entirely different model. It's trained on GitHub repositories. I see. Okay. I've only ever tried ChatGPT so far, and the free version. And I mean, 2 years ago, let's say, that's when AI started being used for these problems. It was already capable of solving a lot of these problems, and it's only gotten better since. So I believe that Eric has basically abandoned trying to outsmart the AI, because you can't. It's unfortunate because that basically means the leaderboard is a mess. It's full of AI. You don't know who's AI and who isn't. At the same time, no one wants to create a witch hunt, because there are people who are actually very good at coding and actually can solve these in like 30 seconds or something, and it's unfair on them to be accused of being an AI or anything like that. So you have to tread lightly, but at the same time, it's clearly a lot of these people are AI, so the whole thing's a mess. I wouldn't be surprised if this is the final year we have a leaderboard and it just gets removed altogether next year, because not only is it kind of a sketchy leaderboard, I'm pretty sure Eric is probably tired of being contacted about this, because people keep asking him, are you going to do anything about the AI, or what are you going to do? How about you try doing this? I'm pretty sure he doesn't want to, you know, go out of his way to try and stop AI. You know, he just offers the leaderboard, it is what it is, and he says, do with it what you want. I mean, he has stated it's against the rules to use it for leaderboard, but that's as much as he can do. He doesn't want any detection methods, because you can't detect AI, no matter who's selling you, no matter who tells you otherwise. A lot of people are trying to sell tools that can detect AI, but they don't work. The only real way to tell if someone is using AI is if they have multiple years in a row of having good times. Multiple years in a row of having good times. You're saying someone who's has consistently good times isn't an AI? And you're talking about years like before the AI became a thing. Because that is one good indication, if people are known for having good times even before AI. But still, it's not a proof, so it's not like we can ban people based on that. Like, someone has good times from 2024 is probably not. Someone with shit times and then suddenly good times. It's an indication, but then there could also be people who, in the last 2 years, decided to sit down and read the textbook on Introduction to Algorithms and study code, or take a proper course, and then suddenly was a lot better, because that's also feasible, so yeah. One thing I'll disagree with is that it's gotten better. 2023 GPT was better at problem solving than 2025 GPT will be. Old GPT wrote an entire ORM for me using just English prompts. Okay. I haven't really played around with the models much. It's possible that they may have downgraded the, like, are you talking about like, well, the free version or the paid version? Because it is possible they may have downgraded the free version and maybe the paid models are better. But from what I've heard from people who use it is that in general, the best ChatGPT models are getting stronger. I'd look at their times pre-2023. That's when LLMs really picked up. Yeah. I remember the first year that it started becoming a thing. It was, yeah, it was 2022. And some people were making blog posts saying, I got to the top of the leaderboard using AI. And the general response was sort of like, that's cool, because it just seems like, oh, you're doing something programming related, it counts. But then people started realizing that it was just a case of literally just asking the AI to solve this for me, and it's not equivalent to, for example, how I used Z3 in problem 13, this one. I use Z3, which is a very powerful theorem proving library. You just tell it the optimization you want it to do, and it just does it. That's fine, because you're still sort of smartly thinking about how you input your stuff to it and how to use the tool and stuff. So that's allowed. And it's not AI, it's kind of... it has one purpose and it does one output. So you're allowed to use powerful libraries like that, but yeah, AI is a different thing altogether. I think the models are getting stronger, but our expectations are also getting higher. That's possible. I heard that day 12 part 2 was a bit harder for AI and that the leaderboard reflects it. 12 part 2 was the garden groups. So I'm guessing the AI probably tripped up on the bit where they cross over. I tripped up on that as well. So yeah, that's plausible, yeah. I can imagine AI would sort of solve it based on what it read up here, but this part which comes down here, it tells you, be especially careful when counting the fence from regions like... That sentence there is quite key, and not... you have to think about it like 3 times when you read it. Basically, here we've got fences around the A's and the B's, so you have a fence going like on the left of these B's, and you got a fence going around these B's, but the point is the fence underneath this A does not touch the fence going above this A. They're completely disjoint, and you shouldn't think of them as touching. Whereas I was thinking of it as like in Minecraft. You just place fences, as long as they're near each other, they will connect as a junction. I believe that if it weren't struggling with tasks it used to complete with these, I can't comment on that. No idea. Alright, so... oh, wrong site. I was looking for Twitch. Wait, so one other thing I wanted to check was the personal leaderboards. Okay, so yeah, 15 minutes is a large time to solve both problems, so that's interesting. And it goes as high as 32 minutes? Okay. How long did it take me? Well, probably 1.5 hours with a bit of waffle. Private leaderboards. Imagine spending hours carefully constructing a prompt with exact instructions only for it to repeatedly send you your own input. Yeah. I don't know. Do you know which model you were using for that? That's my leaderboard in case anyone wants to join. Where's the... in fact, I'll paste it here. GPT-4o Mini free, but I tried it with GPT-4o paid and it did the same thing. And you were asking it, what, to fix bugs or something? Or... I see. I've never tried really using it properly for anything. But I also recommend checking out Captain Coder. He has been streaming these problems as well. He's a bit behind because I think he's on holiday now. But he has got a good channel. You just have to search for Captain Coder in Twitch if you want to find him. And I participate in his Discord where we discuss each problem and how we solved it and stuff like that. To refactor a list of conditions, making a mod for a game. That's weird. I mean, I've done queries like that before and not had that issue come up, so I don't know. Could you check your Twitch DM before you head out? I can, but I'll have to open it. Hang on. I have to open a second browser because this one's got a different session. I'm not logged in on that one. Possible to guess. Alright, yeah, DIJ, I'll get back to you on that after the stream. I mean, I'll give it credit, it's working with a proprietary in-house scripting engine exclusive to that game, but it should still understand that removing whitespace isn't the same as... Yeah. Well, it's strange that you said you tried it multiple times and with different models and it did the same thing. That's quite odd. I don't know what's... whether that's normal experience. I don't know. Coda 2K, happened to code 2024 tag 15 in Kotlin. Bit kein Spoiler. Is this in German?
My filthy little snuggles. Kennt das Zitat jemand? Da bin ich mal gespannt.
Is he in English?
Hat das jemand erkannt?
I don't want to put my... Okay, I put my audio up, but it might feed into the mic.
So, das gibt zurück ein Warehouse. Okay, was muss ich machen? Also ich hätte jetzt im Prinzip die Zeilen, die nur für die Map
well, I don't want to raid someone in German.
und möchte jede Map...
I don't know why Call of Duty is coming up when it's happens of code. I guess that sounds like COD. COD, yeah. Alright. I guess no one's doing it right now. Just COD. Unless you want me to raid COD. No, we're not going to do that.
Aber geht das auch?
Advent of Call of Duty. Whimsically Made is doing it in BQN. Okay. Hang on. Do they have, Ah, okay. Sometimes people write AOC. I should search for that as well. Alright then. We'll raid them. Alright, thanks for watching everyone. I'll be back tomorrow, hopefully. Around the same time. See you.